Thank you so much. Hello, everyone. Great to be here today. And yes, I can only mirror what Shun said earlier. Coding agents are awesome. I think for all of you, coding agents pretty much have become the default. Agentic engineering is the standard as of now. And we first learned that coding agents are amazing in software engineering. May that be fixing bugs or all the way to one-shotting an entire feature by now is very possible. And we later learned that coding agents are not actually only good at coding, but at many other things, such as, for instance, preparing the talk track or some of the slides that I'm going to run through later today. So what's stopping us actually from using the power of these coding agents that's really unparalleled to just bring that into a production scenario? Today, I want to tell you a story where we did exactly this and show you how we built Text AI. That is a self-improving system for text preparations. This not only managed to pre-fill complete text declarations to up to 97% accuracy, but it also increased the throughput of the text practitioners by 50%. So a massive uplift here. A quick bit of context where this story came from initially. I lead the forward deployed engineering team at OpenAI and APAC, FDE for short. And FDE sit exactly at the boundary between frontier model capabilities and this very messy production reality where we have to generate business value. We work directly with enterprise customers and practitioners on these hard 0 to 1 problems. So these problems that just have not been solved before and they just don't have a good solution pattern that's already known. Together with our customers, we aren't only breaking this new ground consistently, but we work towards building production systems that actually show a real, measurable business impact. And last but not least, all the while, we try to stay very close to our product and research organization. You can imagine whenever we uncover a new pattern, that pattern might actually be something that scales across many industries, many customers. And we want to bring that back to make that a democratized version and also push the boundaries of what our models actually are capable of doing. Text AI was exactly such a case that actually ticked all the 3 boxes through the stack. So let's get into it. Let's start with the problem. The company that we were working with was processing thousands of text returns every year, and that means millions and millions of source documents. And a very big part of every text practitioner's job here is data entry. From versatile document sources all the way into highly complex text filing forms. And for a very complex return, a single return can take up to 8 hours of just data entry. Not the most exciting thing to do, really. So one might think, well, that sounds like a reasonably simple thing. I just throw that thing in an LLM and I get the values out and I map it against the form and voila, there's my solution. And this is actually the naive approach that we started with, and it actually worked well for very simple income returns. When it comes to more complex returns, this changed quite a bit. So in this scenario, engineers were able to look at the result, see whenever a practitioner makes a change to a predicted value, maybe follow up with the practitioner, make a change to the system prompts, the entire system behavior, and then push that as a fix to the production system such that the edge case afterwards is consistently handled. Now, as you can imagine, production reality just is not that simple and is not that clean. Hardly ever it is. Once we started to tackle the much more complex text return scenarios that are far less standardized and where structures are just way more complex, complexity on the engineering side also exploded as a result. So for example, a rental property filing might require the engine to take a couple of different PDF documents, handwritten notes, spreadsheets, somehow reconcile numbers across all of these different documents. And in some cases where you have multiple sources of income, it actually becomes more complex where you need complex reasoning to even figure out what's the right text filing structure before I actually fill the text filing form. So you can imagine that each new filing structure here led to more and more complexity. And that ultimately got us to the situation where we had such a long tail of edge cases that engineering was simply not able to catch up with anymore. So the problem was no longer reliably extracting some values from some documents and plugging them into some forms, but it was very much building a system that could consistently improve the complexity of the system itself growing. And that meant engineering really became the bottleneck. And that gave us the actual real design question for this project. How could we build text AI in such a way that it scales without scaling the engineering complexity at the same rate? And a very, very tempting answer here is just use a stronger model. Now, that's the simple answer. That also helps to some extent. But it's definitely not going to be able to encode all this complex tacit knowledge that practitioners have in their heads that is really important to handle these edge cases correctly. So to scale, we somehow needed a system that could consistently capture some sort of failure signal, form that into something that we can improve against, and ultimately ship that into production such that text AI becomes a better system. So how exactly did we build this? At a very high level, this sort of became a four-step loop. At the first stage, a practitioner naturally just uses text AI. There might be a prediction that is wrong, the practitioner changes the prediction, and that actually becomes a signal for us that somehow the prediction was wrong and we have to make a change. Now, that human interaction is actually the most essential part of the entire loop, because that is what contains this complex domain knowledge. Secondly, the product needs to somehow capture not just like that small change in the value from like, say, 30% to 60%, but it actually needs to capture the entire context and production trace. So this is much more metadata around all the source documents, the extracted fields, citations, practitioner edits, and ultimately everything that actually led to the practitioner making this change. As a third step, the production traces then need to somehow be converted into a durable eval set. So something that we can actually use to improve the system over time. Now, the tricky part here is not every correction actually is a valuable data point. Some corrections are practitioner preference. They might just be workflow noise, just simple deviations that are not necessarily a rule. And this is the hard part about like figuring out what is actually the signal in the noise. And lastly, with this new targeted eval set derived, Codex now gets a new hill to climb on. So it can climb against this targeted eval set and actually improve the system. It can then investigate a failure mode, propose a change, run a validation. And ultimately, once a new change ships, the new product then produces more and more evidence around what is it actually that is now the new failure mode. So a critical point to call out here is this is not some magical system that is somehow autonomously in an ungoverned way without change control improving itself. You can imagine financial institutions really don't like this kind of behavior. They want to have control. And that is very important for safety and security reasons as well. So naturally, one part that is quite obvious in this whole context with Codex agents, coding agents is Codex very much benefited from and contributed to each and every one of those steps. So let's dive a bit deeper into the steps 2, 3, and 4. Step 2, the capture. So the collection of product traces, that was actually the most important thing to get right. So let me walk you through a simple example here. In this simple example, you might have like 3 different sources of information. That could be a PDF with all the rent paid. That could be a spreadsheet with expenses that the landlord incurred. But it could also be handwritten owner notes. And in this case, it would be Text AI's job to normalize this package into a consistent, I would say, bundle of information that is tagged against the different fields with all of the source provenance where the information actually came from. All of this now becomes part of the actual production trace, which later might turn into a part of the targeted eval set. Now, as such, failure becomes actually diagnosable, reproducible, and measurable, and hence correctable, instead of just changing some value from 30 to 60%. So Text AI was deliberately built as a product that captures all of this production trace and makes that a useful signal for the improvement loop later on. Now for step 3, the signal. Now we have a lot of these raw corrections, and as I mentioned, not all of these raw corrections are actually useful. So we need to find the useful failure signal within this noise. What's key here is you really want to zone in on those repeated patterns that show up as something that is actually indicating the product is not doing a good job as a whole. So the important ones are recurring patterns. That could be a mismatch of a value to the wrong entity. There could be a repeated practitioner correction over many different practitioners, or even text filing cases, or a similar miscategorization across the entire stack, where it's like obviously always miscategorizing some entry. Once these patterns are identified, it then becomes a hill to climb for Codex, including a hypothesis of what is actually the thing that needs correction in the domain language. With all the evidence that practitioners have put in, including the source documents, the correction they made themselves, and possibly even last year's text filing. And ultimately, it also needs a clear success metric to work against and a targeted eval set. And as you all know, once you actually have the setup of a targeted eval set and a measurable outcome, coding agents are actually really, really good in fixing this problem. So step 4, and that's the juicy one. In the final step, Codex now takes this new hill to climb, and it actually improves against the targeted eval set. The key here is that Codex does not just need the eval set, but it needs a lot more information around the system that it adjusts. So for instance, it needs a writable work tree. It needs some additional read-only resources that it's not allowed to adjust. And obviously the mechanism to validate against. Is it actually like fixing it in the right direction? And is it getting to a metric where it needs to get to? So the writable work tree itself contains a bunch of components that Codex is actually allowed to edit, allowed to modify as part of the system. That could be some skills that define the extraction mechanism, that maybe define even some of the forms that have to be filled in. That could be the definition of the agent as a TypeScript file on itself, so it directly modifies the code in the loop. It could be field schemas that need to be filled, or many, many other bits and pieces of information that Codex can actually adjust as part of this improvement loop. The read-only resources contain a lot of rich additional metadata that Codex needs to understand the larger context. Naturally, this is the source code repo. You really want to understand the product that you're editing, so Codex needs to have access to that. So you can also run typical code quality checks, tests, and so on. It also contains a number of skills that, for instance, tells the agent how to run an eval set, how to run tests, or even how to write a good PR with a decent description such that an engineer can actually review that. On top of that, it naturally needs access to the eval set, such that it actually can climb the hill. This useful separation of static context and adjustable product surface is actually what really matters here. You have editable parts that Codex is allowed to touch. You have production evidence that obviously Codex should not be allowed to touch. And you need this very clear success metric that you're optimizing against. Now, with all of this environment, you can imagine that Codex can inspect and diagnose the failure mode, really understand it from a domain point of view, then make an iterative change to the bounded environment, to the writable work tree, run it against the target and the regression eval sets, and ultimately get to the point, yep, this is no good, and I might just create a PR out of this. So once Codex reaches the satisfactory threshold of like, that's the metric where we need to be, it actually becomes an engineering review. So instead of this, as I mentioned earlier, being like a blind system adjustment that just like miraculously changes the system over time, it is actually a review-governed process. So it really fits into this governed environment. And Codex isn't entirely replacing a product team here. That would be too much. But it's absorbing a lot of like this analysis work and this tedious iteration, how to fix these bugs that practitioners have raised. And of course, we did measure the results of this. Otherwise, it would be a bit boring. And the key metric that we were actually observing here is what percentage of text cases could reach a sufficiently high field level completion ratio such that the product becomes valuable. And as a matter of fact, if for every single text case, the product can actually get to 75% field completion rate, that is actually a really, really useful product. So that became our bar. And when we just implemented the first version of this in week 0, only about a quarter of all the text cases reached this bar. After 3 weeks of the self-improvement loop, it actually climbed to 79, and after 6 to 86. So the system improved itself more than threefold over 6 weeks by the self-improvement loop. We also did the same measurement on much more aggressive field level completion rates, and here the growth was actually even more remarkable. So ultimately, text AI takes a lot, like this large proportion of boring data entry work, takes that away from the practitioners and frees up their time such that their throughput increased by 50%, and they actually have more time to spend with clients to provide quality or premium high-touch experience. Now, to wrap up, I want to leave you with 3 key things that we really took away from text AI and building the self-improving system. The first one is anchor the loop in the behavior of real users. Your domain experts are not just people that somehow label something and a little bit of guidance left and right, but they're actually an integral part of the entire improvement loop. Their day-to-day work is what gives you all of the signal that you need in order to improve the system towards actually performing better over time. Secondly, the product needs to create evidence on itself. So you can imagine for complex problems, agents, or products, just inputs and outputs, just a small change in the system, just user metrics, they're not good enough for agents to actually make a change. You can think of it this way. If you as an engineer, just from whatever data you're looking at, can't really figure out what this is supposed to mean for the system, likely a coding agent can't actually make the adjustment either. And lastly, and this is the key point, create coding agent-based improvement loops. This was a big finding for us, where coding agents were just so much better at doing all of this as compared to regular loops. And once you actually build a system that can create a signal over and over again, and that can create a bounded task with a good hill to climb, you actually have a very effective setup of the agent itself, improving the system more or less autonomously over time with just a little bit of touch points in the process. So overall, text AI is one of those great examples that really make it very exciting for me to work at OpenAI FDE, and at this current state of AI, where we can already do a lot, but there's still a lot to discover. For customers, for instance, we can co-engineer these systems where frontier models are meeting real operational needs and lead to real business outcome, even in very complex and governed scenarios or domains such as finance, manufacturing, semiconductors, you name it. And for builders, it is naturally a super interesting thing to do because you're exposed to everything from model to product surface to developer tooling, all the way down to working very closely with these domain experts that just have depth in what needs to be improved. Lastly, I want to give a huge shout out to Arthur and John, who have been driving a lot of this text AI work. I was merely the presenter here today, and the both of them have just been doing amazing work in driving this impact. So I genuinely hope this was a useful talk to all of you. And last but not least, solving hard production problems is very challenging and is also very exciting, and it is better done together. So if you're working on one of those hard problems, or if you want to build towards solving some of those problems, feel free to reach out and come talk to me. Thank you so much.